Okay, Trig, I'm home with the sick kiddo today. On Wednesday, we started section 3.5, which is operations of functions. You guys already have this worksheet for this section, but we're going to do the last couple examples on the back side of the notes, and then you will be good to go. So starting with example 4, they talk about domain of composite functions. I think we did composite functions the other day. Yep, here we're sticking one function inside of the other, okay? And I said that, like, if you have a number here, you just plug that number into the inside function, then plug that value into the outside function, versus if it just says x, then that means you're literally taking this inside function and sticking it into the outside function, okay? So that's where they're going to have us do here. They're going to have us do g composed of f and f composed of g, okay? But before we do that, let's look at our functions individually. Let's look at f of x and let's look at g of x. And let's talk about the domain of each of these guys, okay? So f of x, his domain, he is a square root function. And what we talked about with square root functions, if you need to write the domain errors again, down on your paper. Domain errors, we are looking for never having one of these two things happen. We never want to divide by 0, and we never want to have a negative inside of a square root. Those two things never can happen. Okay, so this guy, we have to worry about having a negative inside of a square root. So, and this one's pretty easy to do. You can do this without having to do all the steps. You can just say that x has to be greater than or equal to 0, right? Because otherwise, if he's less than 0, we would have a negative in there, okay? Versus this guy's domain, this guy is an x squared minus 5. He doesn't have a fraction, so we don't have to worry about dividing by 0. He doesn't have a square root, so we don't have to worry about that guy. So he has a domain that could be all reals. We can plug in any number we want to in for that guy, okay? All right, so now let's complete part A, which is to do g composed of f. We're going to do that over here. And then let's separate it, and let's do f composed of g, okay? The other day, I think it was Kelsey that maybe asked me, like, is g composed of f and f composed of g, if you use the same functions, will they be exactly the same? And you might have figured out by now that it is not. It is not going to be the same thing, okay? So g composed of f, if you like to write it in parentheses, you can write it like this. This will be g composed of f of x, and this is f composed of g of x. It's like just plugging, it's just using parentheses, okay? So this guy, we're taking f of x and we're stuffing him into the g function, okay? So the g function, I start with him and I say x squared minus 5, but in place of that x, I'm going to put the square root of x, okay? So that f, this is like the f function, and the overall is the g function, okay? And now we simplify. So when you take the square root, or the square of a square root, square and square root go away. So this guy will just end up being x minus 5, and that's what g composed of f will look like, okay? But over here then, if we take g and we plug g into the f function, okay, starting with the f function, f is the square root of x, but instead of the x, I'm going to put x squared minus 5 into there, okay? And now be careful when you do this, because the square root of x squared comes out nicely, but the x squared is really trapped with the minus 5, so we can't separate the two, and really all we end up being able to do is just leave it as the square root of x squared minus 5. Okay, and that's it, all right? Now they're asking for, on part B, they're asking for the domain, okay? Now, don't get into a hurry when you're doing this, because x minus 5 doesn't have any problems here. We don't have division by 0. We don't have a negative inside of square root. So this guy looks like his domain is all reals, except don't get in too much of a hurry, because the domain of this guy, we have to also take into consideration where this function originated from. And this function originated from these two functions here. And so we do like a combination of all of these domains. This guy's domain, if we would just look at just this function, would be all reals. So we have all reals, except x has to be greater than or equal to 0. So we could plug in all reals, except this guy is the one like screwing everything up, and x has to be greater than or equal to 0, okay? So over here, we have that kind of as well, except this guy does have a square root to start with, so we have to worry about him, all right? So let's do that, x squared minus 5, and we don't want that thing to be negative, all right. So let's first, this one we have to kind of do the steps. let's first set him equal to 0. X squared minus 5 equals 0. And we would add the 5 over and add the 5 over, and x squared equals 5. And we would take the square root and the square root, and x equals plus and minus the square root of 5. And that's what he would look like, okay? All right, so we have negative square root of 5, and we have positive square root of 5. And we're going to figure out which one of those we can plug in and we cannot plug in. Okay, except before we start doing that, let's go back over here. We said that x has to be greater than or equal to 0, because this guy's like messing everything up. X has to be greater than or equal to 0, and a 0 is right here in the middle. So we already said that x has to be over here. So we're not even going to look at this range here. We're just going to look at that stuff, okay? So x has to be greater than 0. So we're going to check a number in this range here and a number in this range here. And the square root of 5 is going to be 2 point something, okay? 2 point something. We don't really care what it is. So let's check positive 3, and let's check just positive 1, let's say, okay? We'll check 1 and 3, and we're going to plug 1 and 3 into this function, okay? So if I do 1 squared is 1, minus 5, that's a negative 4, and that's not going to work, okay? Not going to work. And then 3, though, if I plug 3 in, 3 squared is 9, 9 minus 5 is 4, and that will work over here, okay? All of those numbers will work. So the domain of this guy, again, taking into consideration the fact that x has to be greater than 0, we've already kind of done that by putting him on my number line. But x just can't be just greater than 0, because we can't plug in 1, we can't plug in 2, we can't plug in any number between 0 and 1 and the square root of 5. So now we would say that x has to be greater than or equal to the square root of 5, and that's my new domain, okay? So there's kind of how that works. When you're doing composite functions, you have to also take into consideration these original guys and how those restrict you also, okay? All right, so hopefully that made a little bit of sense, you know, whatever. I'm pretty sure the ones you have to do on your homework assignment are way easier than that, but don't quote me on that, all right? Next example, example 5, if you have any difficulties with these or doing any of this, ask Mallory Mormon, because we just got done talking about examples like this in our calc class. Okay, so there's that, all right? So they want us to take this function and break it apart into 2 separate functions like f and g. So call one piece f of x, call one piece g of x, and they want us to break us apart in 2 different pieces so that we can compose them together and create this function, okay? There's quite a few different ways that you could do this. So let's just start by doing this. This one's kind of the obvious one, okay? So let's say we have the square root of x, because that's kind of the outside function, and the inside function is 3x squared plus 1. If we would then do f composed of g of x, we would take this guy and plug him into that spot, and we would end up with this function, right? I could do f composed of g of x, right? That's writing writing h as a composition of functions in 2 different ways. In 2 different ways, okay? So that was one way, right? That's one thing that we could do. Or let's go and say instead, let's say f of x equals, let's do this. Let's say the square root of x plus 1, right? Okay, then g of x would just be 3x squared, okay? And then this guy would look like f composed of g of x, and it's like taking this guy and shoving him in just into that spot. So that's one thing that we could do, right? And you know, there's probably a couple more different options that we could do, but those are probably the 2 main ones that I see. Yeah, those are the 2 main ones that I see. So you know, there's that. You could, if you were to switch like these 2 around, like and put f of x as the 3x squared plus 1 and g of x as the square root of x, then these 2 would just switch places with each other, and it would be g composed of f of x instead. So, you know, there's kind of how that works. But, you know, for the most part, you're just kind of like making up 2 different functions just so that when you combine them together, they end up being exactly that guy, okay? Let's skip example 6, but example 7, I like this example. A circular puddle of liquid is evaporating and slowly shrinking in size, and after t minutes, the radius of the surface area of the puddle is measured by this thing here, okay? So this is talking about the radius with respect to time, okay? So I'm going to write that down. R of t equals 18 over 2t plus 3, okay? So this, again, is the radius with respect to time. Okay, that's discussing the radius with respect to time. Okay, now it says the area is given by A of r equals pi r squared. Okay, and that's what we know to be area, right? Okay, A of r is pi r squared, and this is the area of a circle with respect to the radius, right? It's the area in terms of the radius, okay? Now it's saying express the area as a function of time. So now we want to like bypass the radius part of it. We want to combine this in such a way so that we don't have a radius variable, we only have a time variable, okay? So if radius is equal to this, and here's where my radius goes, all I'm going to do is I'm going to take this and plug this in for the radius. It's like doing a composite function, right? So we're going to do, this is called A composed of r of t, or I like to use the parentheses. A composed of r of t, we're taking the r of t, this equation, and shoving it into this spot, okay? So we've got pi times the radius squared, but I'm going to put 18 over 2t plus 3. And now I don't have to use the 12, plug the 12 minutes into this to find the radius, then take that radius and plug it into here to find the area. All I have to do is take time, plug it in here, and then it gives me the entire area. I don't have to find the radius in the middle, right? Okay, it's just doing both of those calculations at the same time. So I'm going to shove the 12 in here. And we've got pi times 18 over 2 times 12 is 24, plus 3 is 27, and that's squared, but let's reduce the 18 and the 27. I can divide both of those by 9, so this is 2/3. And then if I square that, 2 squared is 4, 3 squared is 9, so I'm going to do 4 over 9 pi, because I'm going to put the pi at the end, and that is going to be the area. The area is going to be 4 over 9 pi, and that is in, what are we talking in? Inches per minute. Okay, I found inches here, so I know I'm dealing with the inches, and then we plugged in 12 minutes. So the area, wait, no, we're not doing, nope, not inches per minute. We're just doing inches squared, I'm thinking of a related rate. Never mind, inches squared. So the area is 4 over 9 pi inches squared. Okay? There you go. All right. So composing the functions inside of each other is helpful because then I can bypass like doing two calculations. I can just do it all in one shot. So that's kind of nice. All right. Your homework assignment, I don't have it posted up here, but you guys have that worksheet. Go ahead and finish the rest of the examples on the back side. You should be able to do the entire back page now. Cray, I said the back page. The back page now. In addition to the front page. So you should already have the front page done, FYI. We will turn that in tomorrow, and we will begin notes for 3-6. Okay? All right, have that done and ready to go.